Welcome back to the Additive Snack podcast. I'm your host, Fabian Alefeld, and today we're venturing into a question on how to accelerate and mature the manufacturing industry. Let's picture a future where values and supply chains are robust and agile, not like they were before. The workforce is skilled in high-tech disciplines such as additive manufacturing, and the manufacturing industry has taken back the important role that it deserves, really, not only within this country, but all around the world. This vision is currently being drawn up by the Green Mountain State and by our guest, Barry Hulce, the Executive Director of the Vermont Manufacturing Collaborative, also known as the VTMC. And today, Barry's here to unpack the complexities of modern manufacturing. We'll dive into the challenges of workforce development and also reveal how his organization is constructing a robust manufacturing infrastructure that really is set to accelerate the adoption of and especially additive manufacturing. So let's get started. Barry, welcome to Additive Snack.
Fabian, thanks so much for having me. I'm really excited to get to chat with you and the listeners.
All right, man. So let's start with you. Your career spans a quite impressive trajectory in manufacturing. You've been in various different roles. Could you distill this journey down for us and how it led you to your current leadership role at the Vermont Manufacturing Collaborative?
You bet. So I feel really fortunate that over my career, I have had the opportunity to try a lot of different things and be within a lot of industries. My journey started out as an aeronautical engineer, where I did stay in that industry a little bit. And I found out that I didn't love being an individual contributor working deeply on one element of something. So I felt like I needed to transition to something that was more people-based or collaborative-based. So my next stop took me to the semiconductor industry. I was there for about 13 years, and 9 of those with Intel. I would say Intel was this amazing journey, a learning journey into manufacturing. It was absolutely world-class manufacturing. I had access to mentors, partners, all of the processes you can imagine for 24/7 high-end manufacturing. And I felt really fortunate. That was where my first start of career in manufacturing came, because it was influential and understanding how all of the pieces of manufacturing, automation, and tools could come together. And that was a great introduction. Over time, I transitioned into other roles into manufacturing and joined Infineon Technologies and Qimonda. And what I started to realize through that in achieving in those companies is that I enjoyed people systems as much or more than I enjoyed the tool system. Tools and technology are amazing. I really enjoyed working with customers and envisioning what problems are we truly trying to solve and how do you bring people together to be able to do that. So that's something I started to learn about myself as I went through this journey. At the same time, a couple friends and I started a company. This was early into the web days, where we would create a presence for companies that wanted to join the web. So we did a lot of custom coding back in the days of HTML and ASP to try to help companies gain a web presence when this was just starting. But they learned from that experience that I don't love coding. And again, I started to realize the draw to people and work with people is what I really like to do. My next transition took me to the energy efficiency world, where the company I worked with was called Efficiency Vermont. It's an energy efficiency utility that represents the state of Vermont. And the mission really was to help people understand where their energy was going, both companies and individuals, and make it affordable for them. Underlying is how do we help people afford the energy that they use and transition to clean energy. And it was really helpful transition for me, having gone from a very product-based, for-profit driven manufacturing to customer service, to understanding, creating, and developing services that help. So that was a really good segue into other things I enjoyed doing. While I was there, I did my master's degree in technology entrepreneurship from the University of Maryland. And that was really intentional to understand elements of, it uses the Steve Blank model, customer discovery, rapid prototyping, quick iterations, because I wanted to try another foray into starting a third business. And while I greatly value the experience I had before, it was time to add some of the academics, some of the fundamentals, like how am I going to do this again? So after leaving the energy efficiency world, I started a product development company with the mission to help people improve their quality of life through comfort and fun. And what that means is I do product design and low volume manufacture. Actually have a little print farm at my house and I work with agencies, that, especially folks that have disabilities, to help identify some problems and challenges that they have. And then I do customer discovery. I watch and I listen and I make a product and I build it. And then when enough people say, I love that, was incredibly helpful, I start making them. So I have a little print farm in the basement that runs. I put the products up on a website and people that need them find them. It's really incredibly fun and satisfying. It's that element of product design and creativity that as I've moved more and more into the management world and running businesses, I really miss that creative outlet, being one-to-one with people and trying to figure out what is it that, your challenge is. So that's been incredibly fun. So along that path, I'll say, people would say, why and how did you dive into all these different areas? And I will share, I asked myself, what am I going to do when I grow up, all the time? And there was this great epiphany a couple of years ago by listening to a gentleman named Simon Sinek. And if folks haven't heard of him before, I highly recommend listening to his podcast or the book. And it's called, one of them, Start with Why, and then Find Your Why. And through that, a lot of self-discovery, and it's really helpful in me going through those exercises. And what I discovered, probably heard through those themes, is I love helping people. And it doesn't really matter what industry. That epiphany for me made me realize is it doesn't really matter what and where it's things I'm doing. It's the why. I'm really drawn to activities and initiatives that help people overcome challenges. I don't really like working by myself. So when I discovered that, all of a sudden, what I wanted to do when I grew up and the why came great. This kind of fun coming together cosmos happened where I had several friends, this was about 2.5 years ago, say, wow, there's this initiative called Vermont Manufacturing Collaborative we just heard about, and they're looking for an executive director to take this idea, this concept, and turn it into reality. It sounds like exactly what you love to do. And I read what it was about, and I realized, wow, that's a great coupling of my passion for helping people, both businesses and individuals, and coupled with technologies I love. So that's really part of our story kicking off, but that's how I got here.
That's an incredible journey, and it's super interesting to see how you moved from engineering into semiconductor, which really is the industry that has perfected repeatability and high performance manufacturing with super high precision tools. Then transition into other industries where you really also understood and tried to learn how to take a problem space into a solution space, and then enhancing that with your additive manufacturing experience, I think is a great layer to add on top of that. And I love your perspective on starting with the why. And I wonder, what's the why of Vermont Manufacturing, the Vermont Manufacturing Collaborative? What is the purpose and the intention of this organization?
Yeah, that's a fantastic question. So a couple of years ago, or a handful of years ago, there's a global assessment about manufacturing capability of different countries. And to anyone here in the U.S. in this space, you know really well that over time, we've outsourced or we've given away a lot of the technology. We've transitioned more into us acquiring the services. However, we've discovered that by doing that, we have huge gaps in our capability of the manufacturing. So the DoD, through different channels, the one being the Industrial Base Analysis and Sustainment Group, which is short, has this ongoing call for ideas on how can we accelerate manufacturing capability in the U.S. So meanwhile, in Vermont, a very small rural place, a lot of the companies that we work with were asking questions about how are we going to gain access to new technology to see what's coming down the line, and where in the world are we going to get the training for people to be able to start utilizing the technology of the future. So meanwhile, the Vermont State University system has taught core manufacturing engineering type of skills with a hands-on experiential-based process for a really long time. There's a lot of success in this core manufacturing. So this epiphany idea came together that said, what if we created, and we wrote up a concept paper, what if we created an advanced manufacturing ecosystem? The intent of that ecosystem is to prove that in a small rural place that you can accelerate manufacturing capability and then take that idea copy that or playbook that, and then go help other small rural communities and figure out how do you do that. Rather than thinking always as concentrated manufacturing, large hubs around the US, we also have to think about how do we do widely distributed, smaller manufacturing center help. And through that idea, we put that together. We sent that idea in, and it was strongly supported. So DoD through IVAS said, that's a great idea. Please go prove that can happen. So that was really the spark of the idea for the Vermont Manufacturing Collaborative. And we got funded at that time. It was about 2.5, 3 years ago. And I came on as executive director 2.5 years ago. At that time, it was just a vision on paper. And today I can say we have a fully functioning, running advanced manufacturing center with people, training, engineers. And we're, in my opinion, the proof of concept is there. And we are now figuring out how do you transition from proof of concept to growing and becoming sustainable.
That's awesome. I really like the approach of trying to grow rural areas through advanced manufacturing hubs and networks. My wife, actually, she's from Central Illinois, which is pretty rural, right? And I think there's a lot of passion in these areas for manufacturing, right? So I think that is the perfect vehicle to revitalize and bring those technologies back into those areas. And we see also, I think, companies like Rivian, who's headquartered somewhere in Central Illinois, and others who are actually exploring those options versus the big cities where we've seen a lot of the growth in the past decades, especially when it comes to manufacturing. So take us through what this blueprint of the Vermont Manufacturing Collaborative looks like, and how that allows you to then afterwards scale that and duplicate that into other regions.
Yeah. So ecosystem is an incredibly important word, because without all of the elements of an ecosystem, it just doesn't work. It doesn't matter if you place high-end tools or if you have really excited people. If you can't build an ecosystem, you're not really going to be able to rapidly advance the capabilities in that area. So a couple of the key elements to talk about. So first are industry. Those are the folks, the companies that need help, and talking to literally hundreds, asking what are your barriers to be able to accelerate what you're doing? How can we help you become more successful? The answer is always 1, 2, or 3 of the same 3 things. One is access to new technologies. So if people, especially in small rural places, don't understand what's the next tool or process coming that can dramatically help them accelerate their productivity or their quality, then they're behind. And that's a huge disadvantage. The second is capacity. So as there's so much demand out there, I've talked to a whole bunch of companies that just are not able to meet the capacity demand. And that's either due to they don't have the tools in place, enough tools, or they don't have the trained workforce. So that leads me to the third element they always talk about is the workforce. If we do transition to other tool sets or add capacity, where are we going to find the people and how do we train them without continuously losing productivity on our tool sets that are there, either the new ones or existing? So then characterizing one element, that's the industry who has the challenges we're here to serve. The second part of the ecosystem are learners. And there are so many people interested and really highly capable in their STEM or making things or having an idea and turning it into something physical and testing it and trying it and breaking it. There's a lot of really curious people out there and would have a great, fun, interesting career, but there's not a bridge to help them turn that spark into ultimate training and find a rewarding career. So that's the learner group. We intentionally say learner because that can be people in high school, that can be people at career technical centers or college. Yeah. College is a path, but it's not the only path. And there's people that want to change jobs. So it's really for learners, how do we help identify those folks and help them along the way to finding something that they really align with? The next element are the partners. The partner organizations are so incredibly helpful. Without being a collaboration, there's no way a very small set of people could make this work. That was a collaboration of the support people. That can be your partners who deliver services. That can be your folks like Vermont Works for Women or United Way that help identify potential learners. It can be the state government who helps find you funding or who helps talk about your program and push it broadly. It could be your partner, MEP, the manufacturing extension partner, who has leads into all of the manufacturing companies. So none of this would work without that partnership. So those are the three elements. Then at the center of all this, what we were able to do with the contract with the DoD was to build a world-class advanced manufacturing center. So we had the opportunity, after listening to a lot of companies, go out and build and select the technologies that were most critical to what we heard the gaps were. And I know we'll dive deeper later into what tools did we pick, but I'll just characterize it as saying, we heard that holistic manufacturing or holistic engineering is really needed. That, yes, some want to dive deeply into this or that, but really helping people and companies gain access to everything from ideation to digitization, making it in many ways, the testing, the breaking, post-processing, the iteration cycle, and making it. We needed to become a center which was able to house and host and talk about and share all of those different things. So that was really the building of that center, the hub. So when people ask me, what services do you deliver? What do you actually do? I would say it's pretty easy because they map exactly to the problems that industry told them. So number one, they say we need access to new technologies. So our center then became a technology demonstration center. So we have including cybersecurity and data enabled, so that we want to demystify many of the technologies, including high-end additives, metal and polymer and CT scanning and heat treatment, all of these really complex topics. So any company that wants to come and observe and get third-party objective advice on process, on tool sets, on technologies, we're there to help. Open doors. We're meant to be a open source, accessible center for anyone manufacturer that needs help. The second part is that addressed the industry problem, number one. The second two about capacity and the future workforce. So we address that by what we call the industry project program. And that is, the outside world looks just like a high-end, high-quality fabrication or production type of shop. We intentionally set it up with the same quality guarantees, on-time turnaround that you would expect if you were subcontracting out manufacturing work. Inside, we are hopefully a workforce of development, talent development, workforce development pipeline. So when industry has this problem and they need the extra capacity or training, they come to us with, here's some projects we need done. We don't have the capacity, we don't have the tool sets. We partner that and we constantly take our learners, call them advanced manufacturing center technicians. We pay those folks to deep dive train on these technologies. We utilize the projects coming from industry to train them on these. So it's fundamentally trying to shift the model of, does a learner have to pay to learn, or can we swap that model or a learner actually gets paid to learn? As we evolve through that, and as these people get more and more experience, we intentionally then make those network connections between the companies we work with that we know have help need in certain areas, and we intentionally develop skills in those areas. We make those partnerships in those introductions so that the learner gets coupled with, introduced to the company. Whether that workforce is being built for that company or the general workforce, it really is just moving to accelerate capabilities within the U.S. One last thing I would say is, at this point, some companies might pique an interest and say, wow, does that mean you're competing with us? I would say absolutely not. Our mission is to help companies thrive. And it would be counter to our mission to then go take business away from the companies we're literally there to serve. So what I'd say is, every time a company comes to us and says, we're really interested in having these products and services made, if we're aware, we know where this can be made, we say, great, here's a manufacturer, here's a service bureau that can do that. Can you go connect with them? Every single time that someone has done that, they come back to us and say, either there's not enough capacity at that place, they don't have enough workers, or they don't have the tool sets there. So we have this really interesting and unique situation where we're able to provide services that we're actually helping to build up so that when we can transition it to the companies. So that's our goal. A service bureau can look at us as competition, but I would say it's exactly the opposite. They call us up and say, we need people to run SLS machines. Great. We're training people to run SLS machines.
Yeah.
You don't have the capacity and you send your projects over here. We're going to get them to the level that you need on your tool set, and then transfer this back to you and hopefully get that person a job with you walking in from day one, being very capable of running the exact process you're looking for. So that's kind of the ecosystem that we're trying to build. And I would say people will say, are you successful? I'd say, I believe that we are absolutely demonstrating that this idea can work. So in the year and a half since we opened the doors and started building this model, we've had over 1,000 people that represents 250 companies come in to evaluate the equipment, get objective advice, and understand, what can they get. At the same time, we've done just past, I think, 125 industry projects. So in a little over a year, 125 projects of companies who need help with technology they either don't have or capacity to train. We've hosted 50 schools, should have the pathway back to the learners, other pieces of technology demonstration center. We host tours, but as well as activity days where we bring in people and we help them get exposed to some of those fun tools. So they'll run a laser cutter or water jet or 3D printer. And that whole idea is to help them down that pathway of, do I like this? Is it fun? Can I envision myself in the future doing this? And really to start to spike that interest so that someday when they're ready to actually do the training or choose school, hopefully factoring and making cool stuff will be one of those ideas that they have.
Yeah, this is such an interesting and crucial concept to building up or building a workforce back up in the United States that is truly capable of also understanding the whole value chain of manufacturing. I think what we see a lot especially in the additive manufacturing industry today is that we take engineers or technicians from conventional manufacturing and we throw them into additive almost in a kind of figure it out as you go mentality without spending the time of truly educating them on the ins and outs of the technology, on the interfaces that you described. And I think that's a hindering aspect of the growth of especially additive manufacturing. Right. So the approach that you're taking, technology, partnerships, and workforce, I think is super interesting. I think has to be successful. And we actually, I'm German, so we in our country we see a lot of apprenticeships programs where, people go into an organization, get paid on day one, and get trained on the whole process as they go. And that may be in manufacturing. That may even be becoming a hairdresser, right? That is just the standard approach here. And I think you're also proving that is a successful model that can happen and work in the United States with obviously additional aspects that you guys provide that are not part of a traditional apprenticeship program. So I'm kind of wondering if we now take a deeper look at additive manufacturing, especially and workforce development, where we have a huge gap in the industry. What has to change in educational systems, and also how does educating somebody on additive manufacturing differ, in your experience, from educating somebody in conventional manufacturing technologies, or does it differ at all?
Yeah, great question. Two part to that. What do I see as the biggest challenges? I break that into there's capability and capacity. So we're trying to teach people how to become capable. And there are a lot of channels for somebody getting into subtractive, like there's a lot of places I'm aware of that will teach people the basic machining, water jet, and others. I'm not aware of any centers that they have true high-end leading edge additive centers. Like most people can get access to a desktop printer, but it's not really the same as having the industry tools available to you. So there's this capability. How do you train somebody with the right knowledge set and also have that right tool set available? I would question how many DFAM classes exist in any high school curriculum. My guess is right now 0. But design for additive manufacturing, eventually, if we're going to overcome additive challenges as just being mainstream, adopted, that does have to be part of normal curriculum, whether college or school or training programs. So that's capability. The next is capacity. You have to have the training mechanisms to reach a lot of people. We can't just train 2, 3, 5, 10. We have to figure out, okay, once we have this material in place, this curriculum in place, how do we help reach a lot of people? So one of our plans, there's solutions. One is on the distributed plan. And that's what we're trying to do, is create a model where you can do very small distributed manufacturing in a center to help, and then place that in a lot of different rural places. So we can prove out that we can do it at a smaller scale comes by replication of what we're doing. I think with small investments, you can replicate what we're doing. So now the opposite side is, how do you reach the masses? One thing to share is we recently entered a collaboration and a contract with two other groups, NCDMM, which is the National Center for Defense Machining and Manufacturing, coupled with the Barnes Global Advisory Group. They are content experts in additive. So the contract that we're doing is we're creating, within the next 18 months, open source materials, we call it curriculum or knowledge packages, about the whole additive supply chain, the value chain. What are all of those elements? So it touches on exactly the question that you asked, is, can we create, let's just use design for additive manufacturing or modified for additive manufacturing, or any of those key elements, creating course content that then anybody, that's open source, that anybody can go grab. And the idea would be, if a high school teacher, instructor, or a college professor, or a workplace wanted to understand a topic, they would be able to go, they would get the knowledge package, and then they can utilize that information in whatever way they need. They can create course curriculum out of it. They can do a return to work type of a program or whatever. It's really meant to bridge that gap. What you asked about is, we've got to get that knowledge out. So I'm super excited about this partnership, because I think I represent the hands-on doing physicality, and they have a tremendous amount of experience, both ideation in that curriculum development, coupled with, they have a lot of operational experience as well. So we really hope to be able to offer out to the world this open source information that helps bridge that gap. Because that's really the only way we're going to be able to accelerate this, is make the knowledge, one, accessible, and two, make it really easy to go get people through.
That's awesome. Especially when it comes to just the basic education of additive manufacturing. I mean, additive manufacturing has such a depth in required knowledge, and some of it is most likely way too deep for a high school to go through. But those standard, what are the standard technologies? What are certain design considerations?
You asked a great question though about, so what's different between subtractive or any other methodology?
Yeah.
And I would contend, I have personally experienced the most advanced thinkers on this subject that I've seen as learners were actually 8th graders. And the reason, like, a lot of times we'll have a high school group come and they're just curious, they're interested. We hosted a group of 8th graders who all had a passion for it. It was a club. The difference was, because they had already explored what it meant to do, and they've not just FDM, but truly additive, they came in with a knowledge base. Like, I was explaining what each technology did, and they're updating me on things on how this worked. And I always put this challenge out there. If you can bring something in that you drew, you can't go to grab it up with Thingiverse. If you truly modeled it up, I will create it for you, so that they would get access to a lot of the different technologies. So I would contend that actually our young learners that are really interested, if they can get access to this stuff, I think that their future of accelerated learning. But that challenge, because you asked specifically, what are the differences? So I would say with any, I've seen semiconductor, aerospace, energy, the facilitization, what do you fundamentally need to run, is different. So helping people learn, like, what does handling of materials that are potentially explosive mean? You can make a safe environment, but you better know what you're doing when you set that environment up.
Yeah.
What do you do with water? What do you do with electrostatic discharge? So there's a whole, how do you create a facility or a safe working environment? Critical number one thing. You don't, and that's one of the things we have in the technology demonstration center. If someone's considered high-end metal additive, we really want them to visit, because you should be fully aware what that means before you jump into this endeavor. So that's a piece of facility. The second then is your approach to doing full design. So I've heard a lot of subtractive folks or high-end machinists say, people believe additive is going to take over subtractive. And I would contend, then you've never actually made a high-end additive piece, because additive means you have to also almost always have a complementary skilled subtractive part of the process. So we'll go back to the delta between design for additive manufacturing and modify for additive manufacturing. huge differences in content that need to help people understand. So there, as additive folks, we would contend there are a lot of potential performance benefits if we can truly create an additive part for lightweighting or assembly joining together. We can make things hollow. There's a lot of performance to be had. We also know that a lot of times it's not manufacturable. So that's now after you create your design for additive manufacturing with all of the benefits you're getting out of additive, you then have to figure out, where do I support it? Where do I anchor it? How do I get the heat dissipation? And subtractive is a pretty well-known process where I would say between tool to tool, there's slight variations. At the end of the day, if you're cutting materials away, there are properties that are well-known. We have so many technologies coming up in additive. The difference between an SLA or SLS or direct metal laser sintering or any of those pieces, people can have a career over each one of those. You approach that very different. That's what I would say in the content approach that's so different is there's things that are already known and tried and true in the subtractive world. I think we've figured out how do you help people gain those knowledge and experience. In the additive, there's a lot of content. I keep going back to, I don't think any one topic is hard. What I really do believe is that the combination of all of the topics are hard. So our mission, our goal is to demystify all of that and make it accessible.
That's a really good point. I do agree with the fact that conventional manufacturing is a really good baseline of venturing into additive manufacturing. And you do need to understand subtractive technologies in order to truly leverage additive manufacturing and its full capabilities and creating applications that can be manufactured at the lowest cost possible, but also considering, as you said, building near net shape or building hybrid, where you add additive material onto a machine part and so on and so forth. And the second part I 100% agree with is there is no such thing really as an additive manufacturing engineer. There is a metal laser powder bed fusion engineer, right?
Yep.
Transitioning from polymer laser powder bed fusion to metal laser powder bed fusion is a completely different animal. Transitioning from FDM into SLS is a completely different animal and requires different thinking, different materials, knowledge, and so on and so forth. So treating those as just one blob is actually quite challenging and not true to the full experience somebody will have getting into those technologies. And speaking about technologies, I would like to ask you to give us a better idea on the capabilities of the Vermont Manufacturing Collaborative from a technology perspective. And if you could combine that with an active project that you guys have worked on for an industry partner that you mentioned earlier, I think that'd be really helpful to understand, how does this project start? What technologies do you guys leverage? And how do you take this project through all the development stages into a final production application?
Yeah, great question. When I talk about holistic manufacturing and what we're able to put together, so we really look at it as the different stages of the value chain. And it can be additive, it can be subtractive in other ways as well. So first we'd start with ideation. Whether somebody comes to us with, they have an idea sketched on paper, it's in their head, or they have a CAD file, or they have a part, we have to take an idea and we have to get it to its digital form. So that route, we have several different learnings and teachings in different CAD platforms, because different CAD platforms, each one seems to have, benefits, and they're all moving ahead quickly in how they integrate things like tool pathing for CAM or additive pieces for tool specific design and features. So we see pros and cons of each, but it's really necessary as part of your toolbox, hopefully, to have some of all. We also, to be able to get your idea into the digital form, we use 3D scanners. We do reverse engineering. We also have a CT scanner and vision systems. So if we can get digital coordinates in whatever means needed, lots of different ways, then our first step is to turn that into a digital format that then we can go manufacture. Then the next step would be figuring out what tool is the right tool or a right tool. I think that's a great learning, because there are often a dozen different ways to make something, and each one has its pros and cons. So understanding which one you're choosing for the why. Why is that one the path I'm going to go try? So whether you go the additive or subtractive path, it's creating those tool paths of how do you tell your machine and equipment how to run. So if we go the subtractive path, we have training and all our sets and learning are meant to build upon each other. So we have manual machines. We have Haas machines, which we have our 3 and 3+1 axis as an intro to CNC. We also have a really high-end 5-axis, it's a 75 model block in the machining and milling type of operations. We also have the fundamental tools, laser cutter, water jet, handsaws, EDM, wire EDM. Do a lot of the different technologies for removing material, but they're built in a stepped pathway where somebody first understands, what am I doing manually? So that then when I translate that into, now I'm having the computer do it, I understand the concepts. I am able to then program and utilize technology to get more and more advanced to be able to create whatever I need. On the other side in additive, we have 7 polymer technologies, and we have 3 high-end metal additive technologies. And I should say that we intentionally duplicated what is either leading edge in industry right now or the next generation. It's like we're not in the R&D space. We're not trying to prove out the new technology. What we're really trying to do is help manufacturers adopt the leading edge technology right now or what's next. So we move into, like I said, metal additive. So we have the EOS M100 and we have the EOS M290. The binder jet side, we have the X125 Pro. All 3 fantastic machines for what they're intended to do. And there's pros and cons of each. And people who have done very small laser bed systems or large or binder jet all know that there are pros and cons of each. And the heat treatment that follows them makes significantly different processes. So we are there. We always say we love to demonstrate technology, but we're vendor agnostic. So we be really open with people, the pros and cons of, one, why did we pick this tool? Usually when we pick something, we did an incredible amount of research and we want to represent to the industry what we felt is reliable, known, tried and true, emerging, has good support. So we'll help anybody connect with any vendor. But I will say we've had fantastic experience with both EOS and X1, our systems. So we do like to host folks coming to see those tools. And polymer, the same thing. We have everywhere from a couple of introduction type of systems with and things that get somebody the hands-on experience of FDM, but rapidly move them through the 7 technologies in polymer that we have represented so that they get exposure to those. And I would say that the SLS process and starting to actually hold powder, we teach with wearing a pepper and all of the safety equipment so that once you've done powder, a polymer-based laser bed fusion system, that you're actually really well on your way to transitioning to metal. So it was important to us to build not just do we have the industry standard leading tools, but as well as do we create a pathway where somebody can learn environment them accessible. It's not starting somebody out from dump them into large scale metal additive printing. It's really meant to a roadmap. Let's see. So after making it additively, heat treatment is absolutely critical. So we have different heat treatments, all of those processes. Some take curing, debinding, sintering, stress relief, all different types of heat treatment. We then have typically the ability to measure it. After you make it, you want to know, did it look like your original design? A lot of ways, vision systems, like I said, scanning systems. We have a really nice CT scanner, an Icon CT scanner that helps us do a lot of analysis, either for QA or measurement back. So we can use it for metrology and QA, QC type of activities. I'll say the number of companies that come walk through and did not really think about, can CT be a solution for actually QA and QC? It's a mind opening. I'll say we love as groups walk through because when they see the equipment, that's when they say, I didn't really think about that, using a tool in that way. And I'll say we do a lot of work where it's like, there aren't a lot of companies that need to buy a CT scanner for the volume of work they do. And if they're not in the case of they need that, but they really need those services once in a while, using a service bureau, understanding the value and why, how quickly you can get some just absolute key data back from CTs is what we're there for. And then after they've tried it with us and they understand, we help them find a service bureau that can set up an ongoing service. So you can either acquire services if you're big enough, or you can outsource those, but it's just raising that awareness. So then of course we have testing. After we make it, we break it. We have all types of equipment for breaking things and squishing them and twisting them and understanding why they failed so we can put it back to how the feedback loop. So like I said, we really tried to create a holistic ideation all the way through production, industry standard tools, coupled with the learning and tool sets that existed at the Vermont State University. So while we're in parallel in conjunction with the school, we really operate pretty independently and then collaboratively, in that if students that go to school there want access to joining the industry project program, absolutely. We love to work with them to come over, but we aren't there to give academic credits. We're there to help people learn the hands-on, experiential based with industry tools. In that regard, the AMC technicians that we hire, some from high school. I have some from center vocational schools. I have some that go to college. I have some that don't go to college. Some adults that are transitioning careers. It really is meant to host any type of learner to get access to that whole broad range of the schools of learning.
Yeah.
I'm happy to share a couple of company examples. If that's what would be interesting.
Yeah, I'd love to hear an example of a company that approached you guys with an application. What was that application? If you can say, what's the company and what was the outcome?
Yeah, I'd love to share two stories because I think they're very different and they highlight potential benefits of what we're trying to do. And so the first one I'll share is a company called Vivo. And Vivo is a really cool company whose mission is to replace and get rid of plastic in the world, starting out with water bottles. And so they made a really cool looking stainless steel water bottle that has a nice coating on it. And it also has a really interesting valve where you can turn it upside down and it will pour out. So one of the problems of the squeezy water bottles is we're used to squeezing them. And if you're on a bike or on a hike, you can't have it just fall out. So they adopted this technology that makes the water bottle, the metal one, acts like plastic one, and hopefully have a very, very long, useful life. So they wanted to differentiate their product, and they got a lot of questions about customization on the outside. So they started out asking companies if they wanted branding and really cool logos on the outside of this water bottle. And the owner of the company happened to do a tour with us, and she saw that we had a laser etch machine and asked, is it possible that we could etch on this? Oh, absolutely. So we did some samples and we started a program where we bring in students or learners. We deep dive train them on being able to do etching, and they make these water bottles that are customized for the companies. They give them back to Vivo. And so we do a subcontract service for Vivo. Why does some people look at it as, well, that's not a really challenging task for somebody to learn how to laser etch. But what we really do is we're introducing people to the entire workflow of manufacturing. So we help the people that do that program. They listen to the customer. They quote the files. They figure out how much is it going to cost. They manage the workflow coming in. They set the schedule of how many do you have to do a week. They manage the quality that they have to go out looking really good because these are going directly to customers that are buying these things, and they have to get them out on time. So we built the environment around a small project or program where the technology is very simplistic, but that's 10% of the learning. It's not really the doing. It's the value out of this program. It's helping people that participate in that get exposure to and ownership for a full flow of actual manufacturing, all self-contained. So I'll use that as a bookend example of the training in the workforce. We're not trying to just teach somebody how do you run a laser etch machine. Operations for any of this equipment is pretty easy, relatively. The opposite of understanding the why and the how and all the processes work is really where the value of a holistic value chain type of manufacturing system comes into being. So I'll use a different bookend now in high technology. And so there's a company that is local to us that's doing international work, is amazing, called Benchmark Space Systems. And they create the thrusters and propulsion systems for rockets. Remember, in small CubeSats and larger micro thrusters and thrusters. Really high end, and they're adapting additive. I mean, additive in this case is really a great potential application because of the complexity of the part, the need for different materials that are pretty tricky to machine. So there's a lot of reasons why additive is a great potential fit for this. Yeah. So they're new to additive. They don't have in-house additive. They do the designs and they're building up their skill sets and capabilities to do the manufacture of the parts, but they need a lot of rapid iteration prototype being made. So really, really fortunate, feel absolutely blessed that they've said, we've demonstrated we can be a good partner, and we do a lot of work with them. So they, after building up trust, they came to us with an additive design and they said, hey, can you make this for us? And we looked at it, and knowing that their new additive design, totally understandable. We're all learning that. We had two choices. I knew that we, the engineer, as we looked at that part, we knew that if we printed as designed, stacked chances of failure was very high because there are critical surfaces, critical features, angles, inside geometries, dimensions that any one of those was going to be a fingers crossed if it printed okay. Couple on all those risks, I felt like it was highly likely that the part was going to fail. So contractually, just out in the world, if you sent out a design to a service bureau and said, make it, you would get back exactly what you designed. And I felt like we could offer so much more. So we made a recommendation, said we have two choices. We can make that for you as is. Here's our best guess of what will look like. Or we can work together really rapidly, and we can break down each of those concern elements in areas. We can do some fast design of experiments. We can print sections and then figure out how is that really going to act? How is it going to work? Redesign the part, and then actually basically do a DFAM and MFAM, because as designed, it would work, but it was not going to be really manufacturable in the DMLS process. So worked with them. They said, thank you. That's amazing. We still were on the same timeline. And he said, great. If you can commit to the fast turnaround of iterations and working with us, we'll commit to doing these rapid iteration prints. So they were able to come in, and we did element at a time very quickly to be able to understand what was going to fail, what we needed to change. So the end result, that design was what we felt had a really good chance of working versus what we had a pretty good feeling wasn't going to work. Along the way, we all learned things. We were actually on the same timeline. And I would say the cost was very minimally more, just the engineer time to think through that design of experiment. But the likelihood of success for the amount of money that was invested was tremendous. And then, so of course, after that, we do heat treatment, and we have the capability of then doing all the post-processing. We can CT scan it. And that's what I say, two differentiations. What's different about VTMC than other places to high-end companies doing this stuff? One is we want to be as open and transparent or closed as they want. If somebody says, I want a black box, make this for me, just send it to me, great. If somebody says, I want to be part of every step in that process, you can come in, you can audit, you can help us, you can be part of it, you can do the design with us. We'll work with you as much as you want through all of those stages and the steps of the production, and pull in any part of our network to help you be successful. The second is going back to the holistic value chain. There are very few or no other organizations that I'm aware of. If somebody said, I want you to take this 3D printed part, and I want you to go through everything. I want you to DFAM it, MFAM it, heat treat it, electroplate it, or post-process it, electroplate it, serialize it, CT scan it, destructive test it, and do back there. I'm not aware of any service bureau that does all of that. So when somebody says we're actually truly trying to qualify something, that's really, I haven't touched on that yet, but that's really the intent, is how do you get additive part of the future? And you have to figure out how you qualify it. Like, I think whether it's through the DoD supply chain or for commercial or for FAA or whatever, there are standards that said before you can use a manufactured part in service in whatever industry you're in, you have to demonstrate that it's reliable, it's safe, it's repeatable, all of those core elements. If we can't help the world figure out how to qualify, quantify, characterize an additive process, and finally get a certification or whatever that industry requires, then additive won't be adopted. So kind of a crux of all this stuff we talked about, why we educate, what are we trying to build? Highest level, we're trying to figure out and working on rapidly with CDMM and the Barnes Group and some other groups. How do you help a company take an idea, go through the entire value chain all the way to certification? If we can do that, then additive becomes viable part of the ecosystem.
Yeah, I mean, you touched on a lot of different aspects of what it takes to be successful in the technology. We could probably run a whole season on qualification, and we've touched on qualification, I think, in a lot of different episodes, especially in our medical series that we just completed a few weeks ago. But I totally agree. And, each government agency has its own approach to it, and each government agency is on a different level of maturity when it comes to additive. Whereas the FDA might be a bit more further along than the FAA, but that also depends on the application itself. So a super challenging part of the whole additive manufacturing ecosystem. But I think ultimately what I think is very interesting is your approach to innovation. And within our group, the Additive Minds team, we also run these types of application sprints, which I think are so powerful to the development process of additive manufacturing. Being able to look at the design, print certain features overnight, look at them again the next day. Did they print? Did they fail? Why did they fail? And therefore, almost taking a software approach to development where I run the code, I see it works, and I adapt very rapidly. We can now do that in manufacturing, and that is such an unlocking mechanism and tool to the speed of innovation in application development. And I think it's very encouraging that you guys approach it the same way. And it's very encouraging to see how you're also taking, different types of applications from a water bottle to a space application through the same process, and it works. So things. Yeah, and you wanted to say something. I didn't want.
Oh yeah, I apologize. I didn't mean to interrupt. I was going to say the value of having multiple systems, and I'll use EOS in particular. So having access to an M100 and a 290 is invaluable. If you need to do something very rapid and an exotic material in a very short amount of time, having a very small build volume to be able to do something like that is incredibly valuable. At the same time, you can model all day, but oftentimes at the end of the day, you have to try the pieces. And to have a large build volume like the M290, to be able to put 5, 10, 20 of our DOEs, I can vary things at a time and do a complete design of experiment in a very rapid, like I said, overnight. I'm not just running piece at a time. I can do 20 design of experiments, all self-built. Yeah. So yeah, I will say having access in our center to having the different types of technologies is also different sizes has really helped us do exactly the prototyping. We can rapid prototype, we can rapid test, or we can do large volume for running.
Yeah, exactly. And if you're a listener out there and you're trying to figure out how to get into additive, I think there's a lot of advice in this episode on how to set up a manufacturing cell, or, in the best case, go to Barry, go through the whole process and learn yourself how to get into additive manufacturing, how to develop additive manufacturing applications, and then start to slowly either outsource or bring it back in-house if that makes sense. Barry, I want to thank you for being on the show today. I feel a renewed sense of optimism when it comes to manufacturing and bringing manufacturing back to the countries that have outsourced a lot of it over the past decades, probably starting in the 40s and 50s, actually, after World War II. And bringing back not only manufacturing, but bringing back the workforce, building a workforce back up that used to be a major contributor to the U.S. GDP. I think 22% of GDP back in the 60s, now down to I think closer to 10 or below. Bringing that back up, I think, can be a huge growth driver and a career driver for a lot of people out there. So thank you for sharing your experience with us. Thank you for elaborating the importance of workforce development and the importance of partnerships, which I think is super crucial when it comes to getting this technology off the ground. I think we should talk more about a partnership, you and I. I think there's a lot of potential there as well, because I see so many overlaps and touch points that I think we can leverage to help the industry out there to adapt even faster. And for everybody out there, we talked a lot about the Vermont Manufacturing Collaborative. We'll put some links in the show notes as well. Also to hopefully maybe the water bottle. I think that's a super unique example. Maybe somebody wants to get it for their organization. So Barry, thanks for being on Additive Snack. It was a pleasure to have you on the show.
I greatly enjoyed it, Fabian. Thanks so much. And as you said, the word collaborative in our name is intentional. I always lightheartedly say that once you know what we do, you're part of the collaborative. So now for the listeners who know what we are, if there are things that for services or things we can do to help you, that's what we're here for, just to people who need help. Thanks so much, Fabian. Appreciate your time.
Perfect. And listeners out there, share this episode with friends to build your own collaborative, your own partnerships out there. This was Additive Snack. I'm Fabian Alefeld, and I'll see you next time.